Welcome to the Building with Metal podcast, presented by McElroy Metal. Whether you're a contractor, architect, designer, or building owner, we're here to help you build better with metal roofing and siding products.
What happens when your solar roof panels outlast the roof underneath of them?
Well, you have to remove the solar panels and then reinstall the solar panels. The typical solar system lasts about 30 to 40 years. In many commercial roofs, they only last 10 to 15 years. If the roof fails first, then you're paying to remove them and reinstall them on the new roof. If it's not playing in their capital budget and, the solar project lifespan and the roof lifespan doesn't match, it can become a surprise that no one wants to deal with when they're having to replace their roof.
So what's the biggest mistake people make when they're considering solar as a rooftop application on their first time?
That they're not thinking that this is an investment, an asset that is going to be there long term. And, one thing that we kind of, always, try to communicate to our customers is that they're installing a power plant on their roof. And it's a living asset, meaning that you have to plan for the installation on a roof that's going to have a long life period, but then also you have to plan that there's operation and maintenance that goes into maintaining the solar system. That's super important. And then there's also operation and maintenance to maintaining the roof and making sure that there's waterproofing and there's a plan for that long term. Also, what we see is when planners, architects, engineers are designing a new commercial or industrial facility, they're not also taking into account the electrical infrastructure that we would also need to interconnect the solar system to the electrical service.
Thinking about adding solar to your commercial building? Don't touch that roof until you listen to our conversation today with Mark Rangel from Spear Commercial, where we're going to talk about everything commercial and industrial customers and architects need to know before they consider putting solar on their roof. Thanks for joining the show, Mark.
Well, thanks for having me. I'm excited. I've been a long time partner of McElroy Metals, and we've done a lot of great projects, and we have systems that have been producing clean, renewable energy now for over 5 years. Thanks for having me.
Absolutely. We're proud to have your systems on many of our manufacturing facilities and have had really good experiences. So thank you for being that partner to us. So let's dig in. How are commercial solar projects evolving as energy demands and incentives are constantly changing?
Obviously, solar delivers energy savings to the facility. And like you said, the incentives are constantly changing, but also a lot of end users, investors, they're really looking at meeting their ESG goals, their environmental, social, government goals, and then they're developing resiliency plans. They're hedging against rising energy costs, and they're also they're installing new loads like EV chargers. A lot of manufacturers are going highly automated, and so as new technologies are coming online that are increasing their energy bills, that's causing their spend to go up, and they're looking to reduce their bills on site. A lot of customers are thinking, should I invest in a project that is off site or on site? There's different pros and cons, but, definitely, obviously owning the system yourself is going to gain you a higher return than buying energy off site. Buying energy off site, that just, you're basically just buying clean, renewable energy that's probably locked in, but that is a capital expense. Where you make an investment onto your property, there's a return on your investment.
That's a great point. I want to talk about return on investment, but before we go there, Mark, you talked about ESG goals, and I'm familiar with what they are, but maybe some of our listeners aren't. Can you tell us a little bit more about those and some of the reasons that corporations, identify those?
So ESG, there's a couple of different ways, especially when a company is publicly traded, that they value the company. Obviously based upon their balance sheet or new technology or new products that they're coming, how stable the industry is, but also they also look at it in terms of their sustainability plan. It's about reducing their carbon footprint, but it's also about being able to track it and have a measurement and verification. Like with your systems, we have a data acquisition system that's a monitoring system that we actually collect the solar production data, and you can see it in real time or historical, but mainly also tells you how much carbon reduction the solar system is bringing your facility. Instead of buying grid energy that is more likely produced by fossil fuels, you're creating clean, renewable energy on your facility that you're able to track and actually use those metrics towards your ESG goals.
That makes sense. So, you also talked about companies building a solar infrastructure to help hedge future energy costs. I think we can all agree, whether it's commercial or even residential, energy bills are spiking, right? And so add to that, to your point, businesses are using more energy, whether it's autonomy, chargers for electric vehicles, et cetera. You make some really good points. So let's pivot a little bit. And you mentioned ROI, and I know that that's going to be a hot topic on a lot of our listeners' minds. And I'm sure there's a million different scenarios that affect ROI. But can you give us a general feel for the things that impact it, maybe what kind of payback people can expect on various systems?
First thing, solar energy, it produces energy that you use on site. And so there's an avoided cost. That avoided cost is based upon the solar energy kWh that you produce multiplied by your energy rate. Your electric bill is split up into a couple different categories. One is energy kWh, and the other is demand or transmission charges, which is kW. We can guarantee we can save you on kWh. And so it's the amount of energy that you produce multiplied by your energy rate. And I think the average cost of energy throughout the United States is right around about 10 cents per kWh. So how much you're paying for energy really weighs into your internal rate of return. Also, the federal incentives. Currently, there is an investment tax credit. The base is 30%. There's also bonuses for energy community, low income, utilizing domestic content. You can get 10% additional bonus for each one of those categories. So we have a lot of customers that are getting 40 to 50% of an investment tax credit. One caveat, the investment tax credit is due to sunset this July 4th, but companies like Spear, we're developing what is called a safe harbor strategy, to where we're investing into products now that are going to allow our customers to secure the investment tax credit till 2030. That means that the tax credit and all those bonuses are still going to be available for the next 4 to 5 years. There's also the 100% bonus depreciation that adds typically another 20 to 25% of the total cost of the project. So just the baseline, you're probably looking at about 50% of the project is subsidized by the federal government through income tax savings. And then there's also local incentives, like McElroy participated in some local incentives where the utility offered a rebate after the project was complete. So, different states have incentives where the project may be exempt from property tax or exempt from sales tax. But generally, if I had to paint it with a really broad brush, the payback is typically anywhere from about 3 to 5 years and about a 20 to 30% internal rate of return. So when you look at it to where a commercial and industrial customer, they have a long-term business plan where they plan to own and operate their facility for, plus 7 to 10 years with a payback of 3 to 5 years. The investment is definitely worth it. Meaning that you're able to get your money back and a return on your investment.
Well, and you mentioned earlier, right, that the typical solar system these days has a 20 to 30 year life expectancy. Is that right?
That's right. Mm-hmm.
So let's pivot and talk a little bit then. Earlier we talked a little bit about the importance of the material or the roof underneath the solar and the life expectancy of that. Let's dig into that a little bit more. So obviously, if you put a 30-year, we'll just assume a 30-year solar system on a 20-year EPDM roof or a 15-year shingle, you're looking at taking that whole system off and putting it back on, correct?
That's correct. And you know how it is, when a system has been out in the sun, sitting up there for 10 years, when you remove it, some of that product is not going to hold up during that process. So then you're having to try to replace older product. To be honest with you, it kind of creates a big mess. When we go and look at a property, if the roof is older than 10 years, we typically recommend that the customer either replace the roof or does repair before we actually go and do the install.
Mm-hmm. And I think that's one of the reasons that metal roofing is such an exciting host for solar, right? We're pushing 50 to 60 year life expectancies now. So you can theoretically, and correct me if I'm wrong, you could go see a metal roof project that's 20 years old and maybe not have to recommend that they have to replace that roof before they put solar on. Is that right?
Exactly. I mean, when I see a big standing seam metal roof, my mouth starts to water. Mainly because with those standing seam metal roofs, we don't have to penetrate the roof. And so We're not compromising the roof at all. Typically on like a flat roof with like a TPO, they make ballasted racking systems where we weight down the solar system, but we still have to have some attachments in there just for very high winds. And so we're compromising that roof, meaning that we're penetrating that roof. And so that's why when we see a roof that's older than 10 years, we don't want to install in there because we take the liability. And so even though, it may still have another 5 to 10 years left on it, as soon as we touch that roof, we assume the liability. That's why, when we see these, standing seam metal roofs, we're able to install more efficiently on there, basically at a less cost. And then also when we assess the projects, we already know that we're not going to have future issues with going and removing a portion of the system or having to do any kind of roof repairs. So we're able to price the operation and maintenance at a lower price because we know that there's not going to be, future risk to our company.
Yeah, that's a great point. And let's go back and talk a little bit more. You talked earlier about the fact that on a standing seam roof, you don't have to penetrate it. In case our listeners aren't familiar with the clamps that you use, maybe explain that if you could just a little bit, Mark.
Both of our partners is a company called S5, and they make products, especially metal roof products, I should say, that basically attach to metal roofs. Now, they can attach to an R panel or a standing seam metal roof, but the one that we like the most is the S-5. It's called a PV kit. And what is it? It uses an S5 mini clamp, and then it has a disc and a module clamp on there, so we can avoid installing a rail, meaning that in most applications, we have to put rails down in order to mount the solar panels to it. We can omit the rail and it attach directly to that disc, which is attached to the S5 clip that clamps onto the roof, and it's a compression clamp, so we do not have to penetrate that roof. Mm-hmm. And those have, it's basically the amount of clips we put on is somewhat the wind rating, and we can get up to 130 mile an hour winds without penetrating the roof, and we can install it much quicker. It's safer. We use the S5 as well as part of a safety mechanism so our guys can tie off onto. And then because we're only having to install the clamp and the disc. We don't have to install the rail. So there's an efficiency of time there. And then, all of our guys, they have torque wrenches on the ends of their drills. So when they're installing those S5s, we know we're installing it to spec, not damaging that roof. So it kind of takes a lot of the complexity out of there with installing that S5 on that standing seam metal roof. And so we're not damaging the roof. It's lower cost because the installation is more efficient. And then especially for the operation and maintenance for like long term, we have the confidence that there's not going to be any leaks.
Yep. And on top of that, right, if for some reason the solar system has to come off, the roof is unaffected because you didn't penetrate it, right? So that's another big advantage. So a little bit earlier, Mark, you talked about some incentives, right, at varying levels, some that are federal, some that Spear helps with. How does somebody early in this process even begin to figure out if solar is feasible for them, and where can they see what incentives are available?
I would love for them to call us.
Okay.
And we can help them develop a very high level feasibility. We've developed some software where we can put in the address, basically just outline a roof, and it tells us how much solar we can put on that roof. It looks at the cost of energy in that area, any local incentives or any federal incentives. And with that tool, we call it Spear M3. We can give the customer what their internal rate of return would be, or their payback, or if we finance the project, what is their savings and what is their like monthly or annual cost of debt.
So you really can be a one-stop shop all the way from an estimate to purchase, install, and even finance, it sounds like, right?
That's right. So we develop projects, meaning that we can assess the facility, do all the energy modeling. We can develop the pro forma, the cost estimate, and essentially the cash flow model so the customer understands the return or rate of return. And then we have third-party capital partners that we bring in to capitalize the project. And then really what our core is we're an engineering, procurement, construction company. We're essentially a group of engineers and electricians that we design and build projects. That's really the meat of our company. But we also have a development arm that has a pre-construction team that we can help the customer assess projects on the front end and bake them and get them ready for the design and build crew.
So is there a fee for that front end kind of ROI analysis?
Nope, absolutely not. I mean, it's kind of like a filter. We essentially, we can run a high level feasibility study like within seconds. And then if a customer is really interested, then they send us their electric bills, and we kind of do like a real proposal. And if the customer really likes our proposal, we send electricians out to go look at their facility, take some photos and some measurements. They come back, we make any kind of adjustments, and we send out a contract, or we send out the financing terms and conditions.
And so Spear is typically all commercial industrial, correct?
That's right.
Mm-hmm. So what would we tell somebody to do if we have a residential listener today? Are there similar partners to Spear that work in the residential space, or are they more on their own? Okay.
So what I would probably do is first go to the NAPCEP website. That's the North America Board of Certified Energy Practitioners website. That's where we all go and get our licenses in order to feel confident that we can practice, distributed generation solar on site. And then you can just type in your zip code and a whole list of companies will come up. And then in their website, they tell you if the company does commercial or residential or both. And then I would pick a company that, focuses on residential from that website. That those guys have the credentials in order to deliver a high quality and safe solar project.
Oh, that's a wonderful resource. Thank you for that. You talked a little bit about contractors when you guys are installing. You talked about, sometimes you have to put down rails if you're on an EPDM or a type roof or a ballasted. What things can contractors do during the install process that either cost the owner money, unexpected money long term, or help them have, a more successful solar system?
The first thing that we always do is, there's kind of like two sides to this equation. One is the structural side, and the other one is the electrical side. So we kind of work them in parallel, meaning that the very first thing we do is we ask the customer for their as-built plans. And we look at the structural of the roof to understand how much weight we can put on the roof and how we're going to attach the solar system to that roof, whether it be a ballasted or on attached to a standing seam metal roof. That is really very important. And most roofs can take solar, but it's like for like a flat roof, maybe you can install a ballasted system, but there's not that much roof capacity. That means you're not able to put so much ballasted weight. That means you're going to have more attachments on there. And every attachment, you have a risk exposure because you may have a leak. And so really, when you're looking at each facility, if you're not accounting for how many attachments, those attachment costs can really add up. And, a typical contractor, they get surprised by it, and then they have to go back to the owner. We weren't expecting this much attachments, causing a change order. The other side is the electrical service. We do get the electrical plans and one lines, but we always send out an electrician to go look at the electrical service, not only the condition of it, but a lot of times after the facility has been built, there's, tenant improvement measures where they've added breakers or they move things around that you can't see from drawings. So we have our guys go out there and take a look at it. Also, we also look at where we're going to put the equipment. The solar inverters, there's different cases where you want them on the roof, or sometimes you want them down below, inside the building, outside the building. You need to have those conversations with your customers, especially for the space on the inside or access to the outside, what kind of environment, what kind of foot traffic you get out there, But to answer your question, some of the number one things that we see is the AHJ requirements for the racking system, like the wind tunnel testing, and then the utility interconnection requirements. So we have a team of professionals that they're on our pre-construction team. We work all throughout the country, and when we're going into a new area, some of the very first things we do, even before we start building a proposal, we start to go look at the utility interconnection requirements and what their expectations are and their guidelines, any studies that we're going to have to pay for them to assess if we can install the solar system. And then on the other side is the AHJ requirements in terms of their structural review letter that they want, and the structural racking plans that they want, to make sure that we're developing a project that is not only going to meet the customer's expectation, but meet the expectation of the AHJ and the utility.
A lot going on, right? And that's one reason it's really important to choose a great partner. Let's maybe back up a little bit. If I'm a building owner and I'm thinking about this, does it make a difference which orientation the bulk of my roof faces? And are there certain parts of the country that do or don't make more sense?
That's a good question. So we love to point the array south. If not south, then west, and if not west, then east. Anywhere from the spectrum of 90 degrees or azimuth all the way to 270. But 180 degrees azimuth is ideal. Areas of the country where it's very hard to make the numbers pencil are obviously in areas that are further up north and where their energy prices are very low. But typically, states further up north, they have higher energy prices because of their winters. So, we have a hard time, especially in areas that the unions are big. We have to pay all of our guys prevailing wage, and the unions typically drive up that prevailing wage cost. Instead, therefore, the whole entire system becomes more expensive. Okay. So areas that have, cheap energy and they're further up north and have unions is challenging.
Right. But again, you make it super simple for people to kind of stick their toe in the water and have you guys give them a pretty quick synopsis of if it could work for them
Exactly.
or not, right? So,
Yep.
so for our listeners, no reason to run away, even if you have, maybe one of those three, but not all three of them, certainly still worth a call to check that out a little bit. So one of the other questions, walk us through what are some of the options for solar now? I mean, are laminates still being used? Are we going to different types now? What are you seeing?
The most cost-effective one is still a silicon-based solar panel. There is a thin film solar panel that is a composite. So the silicon, we typically have been using a monocrystalline cell, meaning that it's a whole wafer, and it's bifacial, meaning that we can collect photons on the top of the solar panel and on the back side of the solar panel.
Interesting. To kind of wrap us up, what lessons do you think has the solar industry learned, or how have products evolved over the last, say, 10 or 20 years?
I would say the biggest lesson I feel that we've learned is that operation and maintenance is just as important as the design and construction. We have built up a very strong O&M team that we can service projects all throughout the country. And we have monitoring systems that give us visibility on the health and the performance of those systems. So it's one thing to build a high quality system, but these assets are in the environment where things are constantly changing. And if you're not able to see exactly what's going on out there and you're not constantly looking at it and not having the tools and the alerts that tell you there's something wrong, then it doesn't matter how well you built a system, it's not going to produce what you expect if you don't have a good O&M plan.
That makes sense. How much maintenance should people expect? Is it fairly common to need some maintenance on a solar system every year, or is it more of an every 5, 10
No.
years? Okay.
So every year there's preventative maintenance. And some larger systems, there's, the frequency actually goes up, meaning that there's a couple times a year that you're going to do preventative maintenance. And then where the system is at determines how often that you're going to have to clean the solar panels. Like we have solar panels that are on breweries and distilleries where we have to clean the solar panels more often because they're cooking sugar and all that stuff is in the air sticking to the solar panels. Or areas that are kind of in the high desert and there's a lot more dust that is flying around, a lot more sterling on the solar panels that we have to clean. I would say that a typical solar system that is about 1 megawatt, we're out there at least with 3 guys for a week, twice a year. So twice a year, 3 guys are out there servicing the system.
And that's fascinating. I never would have thought about the beer facility having sugar in the air and the dust of the desert,
Right.
but it makes total sense. We see some of the similar things on metal roofing, so I just hadn't really thought about the connection for solar and the need for cleaning. What's the best piece of advice that you would give somebody, Mark, that is considering a commercial or industrial solar project to get started?
First thing is that with the investment tax credit sunsetting July 4th, we're able to safe harbor projects for the next 4 years until 2030. So they kind of need to get moving in order to take advantage of the investment tax credits. The second thing is look at the age and their condition of their roof. Because if that is compromised, then they should probably think about making that investment first. And then the next year, think about the solar project. And then the third thing is understand their energy usage projections. We have customers all the time where we're in the middle of developing their project and they're like, oh, by the way, we're adding another manufacturing line or we're expanding our building. And so it's one of those things that we need to have all the information of what this facility is going to look like today and in the next 10 years.
That's a really good point. So you're future-proofing it really as you design the system, right? If I'm hearing right.
Right.
Okay. So how can our listeners find you, Mark, both you and Spear Commercial, if they want to talk to you about a particular project or have a question?
So Spear is spelled just like the weapon, SPEAR, and our website is spearcommercial.com. My email address is mark.rangel, that's RANGEL, spearcommercial.com, and they can contact me, and my team and I can work together to help them assess if solar is right for their facility.
Perfect. And how long have you been in the industry, Mark?
I've been doing this for 21 years. My background's in mechanical engineering. I've been in solar doing off-grid, residential, CNI, and utility scale, but my passion and my focus for the majority of my career has been in the commercial and industrial space. We kind of specialize in portfolio projects. We do a lot of big box stores, a lot of big manufacturers to where there's multiple facilities. That's kind of what we're built for, but we also help small customers and we help really big customers. Really our responsibility is to keep our guys working out in the field and to deliver high quality projects that are going to last 30 years plus.
Well, you have certainly done that as a partner for McElroy Metal. So thank you for that. And thank you for joining our show today, Mark.
Awesome. Well, thanks for having me.
Thanks for listening to the Building with Metal podcast, presented by McElroy Metal. To stay up to date with our latest episodes, be sure to subscribe wherever you get your podcasts. Visit us online at www.mcelroymetal.com for more info and products. Until next time, keep building with metal.